undetermined coefficient, right? Where we consider the function in your right-hand side is a polynomial. Either it can be linear, constant, quadratic. As long it is a polynomial, then your fx, then your yp is x to the power of r, cn xn, cn minus 1 and xn minus 1 until plus vc naught. Okay, where n here, all right, where n here is the highest degree of your function. So if your function is a quadratic, then you should have up to C2 because you have the highest degree n equals to 2. Okay, if your n here equals to 1, the highest n equals to 1 here, then you have up until C1x plus C0. Okay, that one is a polynomial. So now, today, we're going to proceed with how can we solve for the function of fx to be in terms of exponent, which is for case 2. Okay, so same process. All right, when your function is in terms of exponent, all right, then your yp equals to x to the power of r demx. And as you can see here, when your function is cemx, so mx, then your yp here also mx. So the degree of the exponent must follow the function given. Okay, so after that, just choose the smallest r to test whether there is a similar term with YH and YP. Okay, so let's start with this example. All right, same process. What is our first step? We have to find what? Come on. We have to find what in our first step? YH, okay? We need to find YH where we change this equation to characteristic equation. Okay, find what is your M, identify types of roots, and then your YH equals to what? What is your YH here? M equals to what? M equals to, okay, YH equals to AEX BE minus 2x, where M equals to minus 2 and 1. 1 and minus 2 also same. Okay. Okay, then look at your right function. In order to obtain YP, you have to take a look at your right-hand side function where fx equals to 5e to the power of 3x. And following this, your YP should be x to the power of r times with d, e, m is what? What is m here? Okay, so to the power of 3x. So you must follow the general form of YP must follow the degree of the exponent in your right-hand side function. Okay, so now from here you test when r equals to 0. Okay, when r equals to 0, YP equals to DE 3x. Okay, so is there any similar term with YH? This is exponent to the power of 3, exponent to the power of 1, exponent to the power of minus 2x. So no similar term. Then just proceed. Okay, proceed with the next step. So matching with the differential equation. Okay, we have YP already. We should have YP prime and YP double prime and substitute to the differential equation. Okay. Okay, then substitute here. Right, and then simplify and compare with the function in your right hand side. So here all of the coefficient has exponent 3x, so you should have 9d plus 3d minus 2d. So this one is 10d equals to 5d equals to 1 over 2. All right, then your yp equals to 1 over 2e 3x. And your final answer should be yx equals to yh plus yp, right? And you will have just add both yh and yp there. That's it. Okay, so this is for case 2 where the function is in terms of exponent. Same process, all right? But for this case, there is no similar term, then it's quite fast to proceed with the next step. Then you can find and obtain the yp and then combine yh and yp to get yx. Okay, clear everyone? This is very easy, right? Any question? All right, try example 9. Okay, try example 9 here. Same process. Okay, so as you can see from here, when r equals to 0, okay, I believe all of you can proceed with YH. Okay, now let's take a look at this YP. When r equals to 0, your YP is 3e minus 2x. So this is exponent to the power of minus 2x. And this is exponent to the power of minus 2x. So this is what can be meant by similar term. So there is a similar term, okay? Then check again. When r equals to 1, then your yp equals to 3x exponent minus 2x. Then there is no similar term. Then proceed with this yp. Alright? So just matching with the differential equation there. Okay, now your yp is 3x exponent minus 2x. You should have your yp prime and yp double prime. Substitute. Okay, find the constant of, sorry, this is d. Okay, find the constant of d there, right? And you should have your answer yx equals to all right. Anyone has problems with this part? All of you got this? You should differentiate by using a product rule, right? All right, everyone got this? Before we can proceed. Okay. All right, now let's proceed with the next case, sine or cosine. Okay, so we have done with polynomial, exponential. Now it is in terms of sine or cosine. Okay, so in case 3, when your function is either a sine beta x or a cos beta x, okay, then your yp should be x to the power of r, c sine beta x plus d cos beta x. So beta here must follow the value of beta given in the function. And as you can see, even the function is only sine beta x, but the yp should consist both sine and cos. Okay. So again, same process. We have here yp. Okay. Right. Find your ym, find your yh. Sorry, yh. All right. And identify the types of roots there. -2 and 1, so same with the previous one. So ae minus 2x plus be x. Okay, now in order to find yp, you should check with your function where now your function is sine x. Okay, then when your function is sine x, then your yp equals to x to the power of r, c sine beta x, which is beta here equals to 1, plus d cos beta x. Okay, then start identify the similarity between YH and YP. When R equals to 0, YP equals to C sin X plus D cos X. Alright, then there is no similar term because this is exponential. This is sine and cos, so no similar term. Then proceed. Okay, matching with the differential equation here. Your yp equals to c sin x plus d cos x. Yp prime should be what? C cos x minus d sin x. Yp double prime is minus c sin x minus d cos x. Okay, differentiate everything. Then substitute. Right, so substitute here. And compare with sine x. Okay, rearrange for those with sine and then for those with cos. Okay, we have here what this is in terms of sine, in terms of sine, in terms of sine. So minus c minus d minus 2c sin x. Okay, plus minus d plus c minus 2d cos x equals to sin x. All right, so this one is minus c minus 2c minus 3c minus d equals to 1 because this is sin x, this is sin x. And then for cos x, there is no cos in your right hand side function. Then you should have minus 3d plus c equals to 0. So solve this simultaneously, you should get your c and d. Okay, so c minus 3 over 10 and d equals to minus 1 over 10. Then just substitute in your yp. Okay, then your y should be ae minus 2x plus bex plus C is minus 3 over 10 sine x minus 1 over 10 cos x. All right? Is it clear? Is there any question? Try to understand first. B equals to 1. Why B equals to 1? Because it must follow beta value in your function, right? Fx is sine beta x. Okay. Then this one sine x. So 1x. So beta should be 1. Okay. All right. Next, any more question? Roots are minus 2 and 1, right? The YH is correct. No more question? Okay. So that's it. If for case 1, case 2, and case 3, we have polynomial, we have exponential, we have sine or cosine. So this is how we do it. Okay. We take a look at the function in your right hand side, identify a YP, okay, and then check the value of R, and then match with the differential equation by differentiate, okay, according to what is there in the differential equation, and then substitute and compare, find the value of constant, and again combine both YH and YP. Okay, so that is for case 3. Okay, now in case 4. Okay, in case 4, I will explain here. Case 4, let's take a look at this. If your function, okay, if your right hand side function is a combination of f1, f2, f3 up until fn, where this f1, f2, f3 comes from case 1, either case 1 or case 2 or case 3. Either it can be a polynomial, exponential, sine or cosine. Okay. Okay. So now, if your right-hand side function is a combination between case 1 or case 2, or case 1 or case 3, or case 2 or case 3, or both case 1, case 2, and case 3. Okay, if there is a combination of both, not 3 cases there, then your YP should be YP1 plus YP2 plus YP3 according to each function here. Okay. Next, the solution, of course, you should have y x equals to YH plus YP. And since YP equals to YP1 plus YP2 plus YP3, then YH plus YP1 plus YP2 plus YP3 up until plus YPN. So that is how you find the solution of this kind of cases. Okay. Then, of course, we choose the smallest r from 0, and then we have to make sure there is no similar term between YH and YP. That is the same procedure. Okay, the steps are exactly same. All right, but now in terms of types of function, which cases that the function follow. Okay, so now let's take a look at this. We have y double prime minus y prime minus 2y equals to exponent minus x plus x. So this is a combination of which cases? Okay, so 1 plus 2, exponent plus with polynomial. So how can we find the solution? All right. Okay, of course, we need to find our YH, right? I just explained here because the procedure is quite same. We need to find our YH, where YH is to consider the left-hand side differential function. Okay, then we have our YH. Now for YP, okay. All right, let's take a look at your fx. Fx is in terms of exponent minus x plus x. It is a combination of f1 and f2. Then when it is a combination of f1 and f2 here, then your yp should be yp1 plus yp2. So you should find one by one of yp1 and yp2. So yp1 follow f1, yp2 follow f2. Okay, so in your f1, it is exponent to the power of minus x. Then your yp1 should follow the exponential part in case 2. Okay, when f1 is exponent minus x, yp1 equals to x art ce minus x. Check the value of r. Okay, there is similar term when r equals to 0. There is no similar term when r equals to 1. So this is your yp1. Okay, once you got your yp1, then same process, differentiate and substitute to the differential equation and compare just with f1. Okay, and then for f2, when f2 equals to x, so it follows the polynomial of a linear, yp2 equals to x r c1x plus c0, check the value of r, okay, and then substitute to the differential equation and compare only with yp2. The comparison should follow the function, okay, for yp1 compare with f1, for yp2 compare with f2. Then once you obtain the constant, then that is for yp1, that is for yp2, and combine. Your yp should be yp1 plus yp2, and then just combine yh and yp as your final answer. Okay, try it. Try it here. Can you get the same answer? This is quite clear, right? Just what you need to do is to focus one by one for each type of function. Okay? Clear now? Anyone has question? Okay. Try to solve this. Find yp, yp prime, yp double prime for each yp1 and yp2. So compare your answer. All right, so that is for a combination of exponent and a polynomial. Okay, now let's try this. Okay, I'm going to leave you with this exercise. Okay. For the first one, this is just exponent, but we have a condition to apply. Means that just like we did in our first example, okay, you solve the differential part, and then once you obtain the final solution of yx, you apply the condition. Okay, for this one is y0, y3, you just use y. But for this one, we have a condition of y0 and y prime 0, means that you have your y, substitute x with 0, y equals to 1, then you need to differentiate to substitute x equals to 0, y prime equals to 1. Okay, a second part, this is a differential equation, and the case here is a combination of a polynomial and cosine. Okay, and the last part, oh, I think this is done already, right? This is done already. So let's do this two equation. Okay, and then you can proceed with a tutorial. Okay, and in tutorial, if you have this kind of function as your fx, okay, it is a combination of t and e to t, which is polynomial and exponential, and it is combined between it is combined here in terms of multiplication. So you just multiply. Okay, all right, that is how you do it. So this is what we have discussed earlier. it's just about addition and subtraction. Now we have a multiplication. So you just multiply both general form and identify the YP. So that is, this type of equation comes from your tutorial. Okay, so you can proceed. All right, any question for today's lesson? Before you can proceed.